Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 55. Yes, you heard me right. Going over a little bit with some extra lessons that I thought I'd throw in at the end. This particular lesson is going to be on the topic of unit testing. In this lesson, I will explain to you what unit testing is, why unit testing is important, why we do it, and then we will look at how we do it. We'll look at some code that implements it. There's actually a nice framework structure in the documentation that kind of gives you a general idea of what we use, the unit test library, inheriting from unit test.test case, creating our own tests, and doing assertions. And we will be looking at code that actually does it. We will have code that does testing of Quokka stuff, and so we will be testing the adding of hosts to the database and retrieving of hosts from the database. We will actually call into our device monitor and do device discovery and check from the database to make sure that the data is correct. We will do the same thing for services. I've recently done a lesson on recursion. We will actually go through and test both of the methods that I created or functions that I created, test compare data, as well as test print network. So we will have stuff that does all of that and tests it. And as you can see over here, I'm in a loop just printing it out over and over again. Why am I doing it in a loop? Just because I thought it would capture your attention more than just having it be static and sitting there all the time. Anyway, that's what we're going to be talking about. Hopefully this will make sense to you. And so yeah, let's get started. So let's talk about unit testing. I'm going to go over an overview of what unit testing is, since a full 35% of you said, what's unit testing? I actually put that in there as a joke, kind of like who's Chuck Black or David Bombal or a jar of almonds or something like that. But it turns out that 35% of you either humorously or authentically said, what is unit testing? So I figured I should spend some time describing it. Now you can also go to Wikipedia. This Wikipedia article on unit testing is actually pretty good, even though, as you can see, it needs some citations, but it does go through the advantages of unit testing as well as limitations and disadvantages, etc. I'm not going to be able to spend all that time talking about all the different advantages, disadvantages, etc. So I'm going to give you my Chuck Black summary of unit testing. And I will tell you that I and unit testing have a little bit of a checkered past. I originally was more of a scoffer when it came to unit testing, because my experience with people who were unit testers and huge advocates of unit testing, my experience was that they tended to produce very little useful code from a product perspective, and they spent most of their time writing tests that ended up turning out to be invalid because they didn't understand the environment or what we were trying to do. And so it ended up being kind of a waste of time. But now, in the last 10 years at least, I have become an advocate of unit testing. I can't imagine a project being built without significant amounts of unit testing. Projects that I've worked on, somewhere between probably 30 to 40% of the code that was written to unit test the product, because the product was something like this. It wasn't a tiny little script that you can just run and either it works or it doesn't work, but it has many moving parts, and each of these moving parts need to be validated. And anytime you make a change in one spot, it can have ripple effects in other spots, and therefore you kind of need to be sure that you're not breaking something in one location when you make a change in a different location, and you want to make sure that things work. I mean, wouldn't it be nice, once you've written a piece of code, wouldn't it be nice if you could push a button and say, okay, does everything still work? And it would go off and test that for you. If that was a human being, that'd be nice if you could pay somebody to do that, to do all your testing for you. But unit tests have the advantage of being automatable. And so being able to automate your tests, you can push a button and you can, with some amount of certainty, be fairly confident that your code still works the way that it was intended. And I've run into this many times on a number of projects where somebody does make a change and it breaks the unit test. Sometimes it's true the problem was in the unit test, but sometimes it was an unintended side effect of what somebody had done had caused something else to break somewhere, and it's a good thing we had unit tests to test it. So that said, let's talk about what unit testing is. Now here is a picture that demonstrates the general idea. This is the Quokka that we've ended up with in our 52 weeks of Python. We've got our workers, we've got our monitors and discovery and scanners. We've got user interfaces in terminal manner as well as actual user interface. We've got a database backend. We've got our Flask service that's running, our Quokka server that has RESTful APIs, deals with the database, deals with making requests to go have work done, etc. So there are many moving parts here. And so in this idealized picture, I've shown you how unit tests might be created. Now, I have not gone through and created unit tests for all of this. In fact, complete honesty, I didn't create any unit test as I was building this class, and perhaps I should have. You could probably make that argument. You may think less of me because I haven't. You may think more of me because I haven't, but I haven't. However, for this lesson, I have created some unit tests, and you can see the output of those unit tests over here, and I will be going through that. But here are some general ideas, some general categories of how I might have designed unit testing to work had I done unit testing for this entire project, and I might indeed do this now that I'm on week, I can't even remember, 54, 55, something like that. Now that I've done that and it's out there, I may spend some time doing this. But one thing I might do is have some unit tests that tested Quokka. What would I be testing? I would be testing the RESTful APIs to make sure they all do what they're supposed to do. I might write some tests that test the database. Now I could go directly to the database to test it, or I could go through the RESTful API. Something that I did do up here is testing discovery for both hosts, as you see in the picture. I drew it just one, but also service discovery and monitor discovery, which if you've gone through the course, you know that that's just reading YAML files and storing them in the database. I could test the monitoring capability of these different processes that I've written, applications that do stuff, and I probably would want to do something that tested workers. Now, why would this be important? Let me tell you about different types of testing, and I'm going to simplify things and give you 3 different types of testing. One type of testing we would call system testing. That is where you test the entire thing running together. That's kind of what we've done when we've run these host displays and the user interface. We have visually inspected what was going on so that we knew that our Flask Quokka server was working, and we knew that the database was working, and we knew that our monitoring and scanning and discovery process were working, and we knew that our workers and the message broker, etc., were working as they should be by looking at this user interface as a human. This is also called real-world testing, and if you want another phrase for me to throw out there, we call this eating our own dog food, and the general idea of this would be if I was building something to provide a particular service, then I would become a user of that so that I would, my day-to-day life would be dependent on it working. So for example, in this situation, if I was monitoring my own network by using this functionality, I would be eating my own dog food. A better example perhaps would be something like a Wi-Fi login service like network access control, where you get into your wireless network by providing credentials or some type of manner like that, and eating your own dog food would be using that on your own network where you're doing development of that same product. But system testing, the general idea, I've gone off on a tangent there. System testing is testing the entire system together. Another type of testing is integration testing. Now that is where you take a particular component, let's use this Quokka server, and you attempt to integrate it with something else, like let's say the user interface that's attempting to use those APIs, or the monitors that are attempting to update and add devices, hosts, services, etc. via these APIs, or the worker. We would be testing to make sure that the message that I sent from this Quokka server was received by the Quokka worker. Now with me, I've developed everything myself, so integration testing, I'm probably doing it every moment of the day. But if you have multiple people working on stuff, one person is a database person, one person is the Flask person, one person is the user interface, one person's doing discovery and monitoring, one person's doing the workers. Now you would have a design like this, and you would decide what the interfaces would be, but you would then go off and implement them. And if you waited till the last minute to try to throw it all together, you would find out that many of your assumptions were not complete and they didn't work out the way that you meant them to. And therefore, doing that integration testing as you go is an important thing. So that's system testing, that's integration testing, that you do integrations as you're building your product. And the third thing would be unit testing. The idea of unit testing, and I've kind of gone down in scale. System testing is everything. Unit testing is an interface between a couple of entities. Unit testing is testing a single unit to make sure that it's working the way that it's supposed to. So, for example, I would be, if I was developing this, then I would have unit tests that made sure that my APIs were working the way that they were supposed to. If I was testing the code that got access to the database, then it would be testing the code that actually accessed the database that I had created, etc., etc. So a unit test tests an individual piece. Now you may say, well, what's the advantage of that? Don't you find that out if you're doing integration testing anyway? And the answer is yes, you do find that out when you do integration testing. But isn't it embarrassing when you get together with your colleague and you test something and you find out your stuff doesn't actually work? And not only is it embarrassing, it's a bad thing to happen. And consequently, you want to be able to have some level of confidence that the thing that you built is actually working the way that you intended it to work. And that is what unit testing does. It gives you confidence that what you've built is doing what you intended it to do. So that's one advantage. Another advantage, and this is the hugest advantage possibly, that is that these are all tending to be automated. So when I said wouldn't it be nice if I could push a button and be confident that the change that I've made is actually working and didn't break anything else, well, that's what unit tests give me. They give me the ability to run tests in an automated manner, similar to what you've seen out here and to what you can see down here. This is PyCharm is built-in unit testing support. Gives me confidence that things are working. And when you work on a real software project, what's going to happen is you are going to be committing your code via Git or whatever mechanism you're using for source control, and builds will be run on your code. And in addition to building your code, it will be testing the code. So this is what unit tests are especially good at, and that is making sure that everything works as you intended it to. Now, does that mean you can get rid of system testing? Absolutely not. You need to do real-world testing to make sure that the final thing is what you intended, and that is where I had some issues with some of the people on my teams in the past, where they actually did all unit testing and no system testing, and when they got time to actually see it work in an entire environment, it was failing magnificently, and it ran all the unit tests correctly, but from a system level, from a product level, it didn't work correctly. So you need all types of testing, but what we're going to be looking at here specifically is going to be unit testing. That is testing individual pieces of functionality in a manner that can then be automated. So let's look at the code that I created to demonstrate unit test functionality in Python. So I've created a new module, module 13, called unit test. And let's poke down here first. I've created one test module called test quokka, another one called test recursion. What I've done is I've taken the code that exists in these other modules and put it inside here just to make sure that I have control on it. And actually, as it turns out, I've found through the unit testing that I can improve this code that I wrote. So I've improved it in here so that I'm not mucking around with it back in these other lessons. So I have my two tests, test quokka, test recursion. In order to do test quokka, I'm going to be utilizing the quokka server code. So if we look in here, this should look somewhat familiar to you anyway. There's all of the host monitor, host display, host port scan, device display, device monitor, DB APIs, etc. All of this stuff is copied over, and you will see that there's a couple of things that I've changed in that, but that's not critical right now. For test recursion, I took what we did in module 12. So just to go over really quickly, Quokka server I took from the Swagger one, so it has everything that I've added to it up to this point, so it has Swagger capability. Recursion comes from module 12, and indeed I did have to change some things in recursion to get it to work better and to make my unit tests a little bit happier so that I could end up with these nice green check marks and things when I run it from the command line correctly. So let's ignore devices.yaml and services.yaml for right now. It's just where the devices and services are going to be input from, and it has to do with the working directory, Python path, etc. So that is the general idea of where the code that I've created, or the package that I've created in order to run this. I'm going to make this a little bit bigger so that we can see it. So before we dive into that, though, let me point something out. Now, quite often, I'm not a huge fan of this documentation. It seems to be written for people who are used to writing. This Python documentation is for people that are quite familiar with Python, and you may get bogged down if you've gone in here to look for stuff and found out that it's talking at a higher level than you're interested in. So from that perspective, it's not always that great. But at the beginning of this discussion of unit test, it does give a basic example, and I do want to have us look at this because this is fundamentally what you'll be doing when you're writing a unit test. The first thing you'll be doing is you'll be importing the library called unit test. The second thing that you're going to be doing is you're going to create a class. Remember from our discussion of object-oriented stuff, our class starts with a capital letter here, and we use camel case. So you'll create a class, name it whatever you want. But what about this stuff inside the parentheses? If you recall from our discussion of object-oriented programming, that means we are inheriting something. And what we're inheriting is this thing called test case. Now, you don't have to understand all the details of what goes on behind the scenes with unit test case, but just understand that you are the beneficiary of a lot of unit testing functionality that comes to you for free because you're inheriting from test case that comes out of the unit test package or library. Now, what you're going to do is you're going to define methods within your class, and every method is going to be a particular test that you intend to run. In this example, they're not doing anything really interesting. Test upper, test is upper, test split. I'm going to go to my code really quickly and show you. And what I'm going to do is a little trick that we learned. I think I showed this to you before. You see this little dash. So I'm going to collapse all of my functions. So here is my test recursion, my test quokka module, and inside it I have a class called test quokka. We understand what that is. That's just the name that I chose. We are inheriting from unit test.testcase, and then I'm defining tests, and this is important. Mark this down in your brain. if you want certain functionality like what you see here in PyCharm to work as you're hoping it will work, then you'll want to name your tests test underscore. So you can have anything you want after that, but test underscore tells this IDE that this is a test. And frankly, I actually don't know. I should have looked this up. It may be involved with unit test when I run it out here, but I'm not 100% sure. So just go ahead and do it. That's what we always do, is we have test underscore. It helps anybody who's reading this as well. Why? Here I only have 3 methods and they're all named that. Well, as you can see, there may be other stuff going on. I may have a method in here that's not actually a unit test, and this would allow me to name it something without test underscore, and the unit test framework, the runner, will not attempt to run it. So this tells the unit test running functionality that, hey, you need to run this and run this and run this. And so that is why we do that. So that is the second thing to notice, or maybe it's the third thing, I can't remember. It's one of the things to notice in this piece of documentation here. And the last thing that I want you to notice is this. This is where the rubber meets the road. This is what you will be doing. You will be calling assert equal, assert true, assert false. And you notice it's saying self.assert true. You need to do that because we're inheriting from test case, and test case has defined assert true for you. So self.assert true is going to test to see if the result of the thing in parentheses is actually true. Assert equal, you're going to give 2 things separated by a comma, and it's going to test to see if those things are actually equal. And so that is the general idea of what you'll be doing. And if we go and we look at my code here, test host, I don't want to run that. I want to expand it. You'll see that I'm doing a bunch of stuff, but oh, here's something where I do an assert equal. And here I do an assert true, assert equal, assert true, etc. So I'm doing a bunch of these different things in order to test that I've got the data that I am expecting. And if any of these fail, then it will cause my testing to print out a message telling me what actually went wrong. And what it will print out is this thing right here. And what you can see is that here I didn't put any text. Is that because I'm super smart and I know that I don't need to do that? No, that's not true at all. It's just that I forgot to do that. So I'm going to fix that right now. Okay, so always a good idea. If it's going to fail, you want to print out something that says why it failed. And I suspect I have this same bug in test devices and test services as well. But that is my test quokka. We're going to look into it in more detail in a moment, but this is again my high-level view. Remember, we're just kind of looking at it at this level. My test recursion is going to be similar. I'm going to have test compare data and test print network. Those are the 2 functions that I created in my recursion program that we looked at in the last lesson. And so what is test compare data going to do? Well, if you recall from my discussion when we looked at, let's see, compare networks. This is compare networks. I'm going to look at this code that I wrote to do compare networks. I wrote this compare data function, and then I have all of these tests to make sure that it works correctly. And I know I had it in my mind. I can't remember if I said this is like doing unit tests for it, but what I actually have done is in test recursion, what I've done is I've taken those things directly from where it existed before in my recursion directory and compare networks, and I'm using those as individual portions of this particular test case. Now I could have written this so that compare data had compared data equals, compared data modified, with silly name, compared data remove item. I could have done multiple tests, but I chose to do them all as one test. It's kind of up to you how you do it. There's pluses and minuses. Of course, you don't want this to get to be huge, so there's some limit to how big you want it to be, but you can break it up however works for you. And as you can see, what I'm doing is I'm printing stuff out, and then I'm doing assert true. Down here, I am going for my next test. I'm going to be doing assert false. And so anyway, you get the idea. I have these asserts that are going on in here, and print network will be the same. Just really quickly, print network, I am printing it out, and so I'm not really able to test that, and we'll look at this in a minute. I'm basically turning off printing and having printing go to output, and then I'm doing check output. In order to do check output for my recursive program, you'll notice up here I wrote something that does that performs this check output, and guess what? It's a recursive function. And I'm not doing an exact check because the data is randomly generated, number one, and so I just really am checking to see if certain things are there, and we'll look into that in a little bit more detail in a minute. But that is a high-level overview, both of what your code is going to look like. You'll have a class, you'll inherit from test case, and then you'll have test underscore whatever. And if you wanted to just get started, you could just say assert true for the return code of every one of these, and it would work. But when you begin to flesh out and add more data, add more tests, then you will get to have more interesting stuff like we have down here in these tests. So that's a high-level overview. Let's look in a little bit more detail now. So before we go into too much detail, let's look at how we run these. So one way to run these would be for me to right-click and come down here and say run unit tests in whatever. You can also debug unit tests. So it's just like running the program normally, but it gives you this nice handy output to tell you whether they succeeded or failed. If something did fail, then you can click down on it and you'll be looking at what exactly the output was and if there was a failure of some type. And this is all of the output that you can see. So that's one way to do it, and test recursion would be the same thing. Here I am running it. You can see that goes really fast. Over here, if I want to run it, what I'm going to do is I'm going to say clear, and then I'm going to come and I'm going to say Python -m unit test. So I'm running unit test modules, and everything is .py that's in that particular directory. I can specify a specific module if I want, but I'm not going to go into that, but I can run it from here, and you can see that I'm actually running all of the tests. My tests were testing devices, so you can see I have chosen to print this stuff out. Some people prefer not to do anything, and they'll when you run it, it actually just prints this dot to show that it has run a test. I like to print out what happened so that if something failed, I can see pretty much right away by just looking at the output. That's my test devices. Here's test hosts, and so I'm with test host, I'm actually adding hosts. With test devices, I'm reading them in from YAML. That's what discovering devices is actually reads them in. And then services, of course, it reads it in from the YAML file as well and populates the database. Now, one thing to note, I am running, and in fact in test Quokka, I make this point. These tests require that the Quokka server is running with the testDB database. We'll look into that in a second. I actually provide, I actually run it like this, and it is going to be, it's going to look for testDB, and if it's doing testDB, then it will use a database called testDB, so I'm not messing up my normal kind of quote-unquote production database when I do that. This is the command that I've run, and if we were to go over here, that's what I'm actually running at this, in this probably looks familiar to you. This is my Quokka server that's up and running and doing stuff. So yeah, that's what's up and running, and that's required for doing testing of Quokka. And with test services, with test devices, I'm checking these devices to make sure that they got read in correctly and that they got stored in the database and that I can retrieve them from the database. And the same thing is true with services. There's more services that are existing on my system anyway. I have all these different services. And then for compare data, I have a few different things. One is where I do the compare data of my code and it's successful. Then I modify that name to be a silly name or whatever, and it's supposed to fail, and it does fail. So I've written out successful, and I've removed like a device, and just like we did in the previous lesson where we looked at the recursion, and then in this situation I added a couple of loops and it detected it and it worked. And then for printing the network, let's see, I didn't make that quite wide enough. Print network, I do my check output. I do check a number of the items, and you can see that I ran it twice, once normally, and then I modified the the actual file to have, not the file, but the actual network data structure to have loops in it, and it successfully did it and was able to avoid those loops. So that is how you run it. Next, let's look at the code in more detail. So let's look in detail at this test. This is test hosts. Basically, what I'm going to do is I'm going to be calling into this REST API. I'm going to be adding hosts to the database, and then I'm going to be reading those hosts back and comparing them to what I added to make sure that this worked correctly. In the host situation, I'm cutting the network out of the picture entirely. We're not doing host discovery, which I do in this host monitor functionality, and actually uses SCAPI, I think, to do ARP pings to discover the existence of hosts. I'm not doing that in this situation. I'm just going to go directly using some canned data that I've created, and I'm going to make REST calls to add these devices, these hosts to the database, and then I'm going to come back and read all the hosts and see and make sure that it matches up. So let's look at the code that implements that. Here's test hosts. Here I'm printing it out. Don't worry about this. This is just fancy code that gives me basically this line right here. So I have to get the name of the class and then the name of the function, and it's not easy to do, but this is some stuff that I figured out is a way to do it. Now I'm going to store hosts into Quokka. How am I going to do that? I'm going to iterate through test hosts. Test hosts, as you can see, is what I've defined right here. It needs to fit in general the design of the host table that I'm using. It's actually going to be a Mongo database, so I have collections and documents, but you get the idea. I should have these type things, and in fact, if we were to look, I can show you that I've actually got my my host display running right now, and you can see there's things already in the database. Now that was 9:16, which is when I ran this test about 45 or so minutes ago. So we'll see this last herd change when I run, or if I was to run it, we would see this change, but nothing else. I'm just updating these, and if nothing was there, it would add them, because as you recall, when we do a put to our Quokka server of a host, it will either add it if it's not there, or it will update it if it is there. And so that's what's going to happen. I'm going to iterate through my test hosts. That's these two hosts that I've got, and for every item in there, there will be a key, which is the host name, and the actual data, which is the host. You see this is the key, this is the key, and then this is the data. This dictionary right here is the data that I'm going to send in there. So I'm going to do a put. I'm using the request library to do an HTTP request to localhost, where the Quokka server needs to be running, to the endpoint hosts. I'm passing in as a parameter the host name, and the JSON data I'm passing in is this host thing, which is this dictionary right here for the second one, and the other dictionary for the other one. So I'm going to go through and iterate through, and I'm going to put it, And then what I'm going to do is I'm going to make sure that it succeeded. That's all I'm going to do initially, is I'm going to check the response code to make sure that it's 204, which is the response 200 type response that says there's a response but there's no data. And if it fails, I will print this out and print out what the response code. And if it doesn't fail, then I'm going to print hostname stored into QuokkaDB success. If we look over here, here's the hostname stored into QuokkaDB success. So we see that that happened. Now what I'm going to do is I'm going to go retrieve all of the hosts from Quokka. So if I was to look at this, I'm going to go in here and say, get me all the hosts. It's going to go into the database, get all the hosts, and it's going to return them to me. So I'm basically going to be retrieving all of the hosts, and I do that with a get and with my endpoint being hosts plural. And so I come in here and I get all of the hosts. Now the first thing I do is I make sure that I got a 200 back. So I print out that I was expecting 200 and I received something different if I got something different. And then what I do is I'm going to translate the actual JSON data that I received, the payload in the response, and I'm going to save it in this thing called hosts. And then I print out, I received this many hosts. Let's see if it printed that out. Yeah, it retrieved 2 hosts success. So I print that out. Now the next thing I'm going to do is I'm going to step through all of the hosts that I just received. You see here is my for loop. I'm going to go through the hosts that I received, and I'm going to compare them to the test version that I sent in. And if they compare successfully, then everything's going to be good. As you see over here, they did compare successfully. Let's look in a little bit more detail. I do have 2 other assertions. The first thing I want to do is make sure that hosts, this thing that I got back from my get call, I'm going to make sure that it is a dictionary. And if it's not a dictionary, then I'm going to say, there's a problem, it needs to be a dictionary. The next thing I'm going to do is I'm going to look at hosts and make sure that the length of hosts is equal to the length of test hosts. And remember, the length is the number of, it's this thing, that's that length, not the length of this dictionary, that's a totally different thing, but it's the length of test hosts, which is going to be 2. So that is what I'm comparing. I make sure that it's the same length. I could probably go through and you can imagine other tests that you might do, but basically as I go through each of these hosts, the first thing I'm going to do is I'm going to make sure that host name, that's what I got back as one of the items from hosts. So I'm going to make sure that host name is in test hosts. So I'm going to be getting something ideally that looks like this, but I'm going to go through and get the first key, which is host name, and make sure that it's in test hosts. So I'm making sure that the key from hosts that I've got, that I'm iterating through, is in test hosts. And it is. And so I'm not printing anything out there. The next thing I'm going to do is I'm compare host, that is the actual dictionary that I got back. This is it in test hosts, but it will look like this basically. Let's see if I can get this to work correctly. I'm basically checking that host item, but from the host that I got back, remember, and I'm checking to make sure that it matches test hosts with the key of host name. So the first time through, I'm going to be checking my hosts. I'm going to be checking it against this. The second time through, I'll be checking it against that. And I'm going to be, remember, this is a Python comparison, so it's going to be comparing every item in there. It's not comparing its existence. It's comparing that it matches perfectly. And if it does, then everything is good. And if it doesn't, then it will say that it's not equal. And so that is what our test accomplishes. This is what test host does. And as you can see, it compared the host, and I ended up with success. So let me point out a few things about our test devices test, because it's different than with hosts. The first thing that's different is we're not creating our own devices, but we are actually calling into the functionality that exists in our device monitor program. So basically we are going to call here, you can see from Quokka server.device monitor import discovery as device discovery. So basically I'm going to call discovery, but I'm going to call it device discovery, but that's from the actual Quokka server code. So in this picture, I'm actually calling this thing right here is something like this, except it's going to the device monitor. So my test discovery for devices is going up to the device monitor functionality, and that's one reason that I have it right here. And I actually found that I had to make some changes to device monitor in how I had structured things in order to make sure that it worked. But getting back to our test devices code, this is what I'm going to do. Now, this, all you need to know about this is I am causing output to not get printed out. So this is a way to suppress all those print statements that I do in device discovery. I just wanted this to be cleaner when we run the tests. So that's all that's about. So I call device discovery, and presumably that's going to populate the database with device discovery information. And now what I'm going to do is, in order to do tests, I'm actually going to, this is collapsed. So I'm actually going to call my YAML functionality in order to read this devices.yaml file. That's why I have devices.yaml here. I was running into issues with respect to where it was looking for devices.yaml, and I found that this is the easiest way to do it. This is not by any means the absolute best way to do this, but for the purposes of our class, I just put it right here so I could read it. So I'm reading that in, and I keep it in devices from file. Now the next thing I'm going to do is similar to what we did before. I do a get to get me all of the devices. Now I'm going to come through and make sure that devices that got returned, that's from response.json, is the dictionary, and that the lengths are the same. Now one thing that you might say is, well, why can't I just do this simple comparison to assert that the devices and my devices from file is the same down here? And the answer is this functionality right here, device discovery. It not only reads it from YAML, but if you recall, it goes out and actually tries to contact the device, and it gets its IP address, and it does some networking stuff. So this is something to bear in mind. This device monitor actually is going to go out into the network and do stuff. And so you need to be aware that that is happening. So it needs to, running this test, I needed to have access to my devices. Now the devices are actually in the cloud, so in theory they should always be there, but just be aware of that. That's something that you need to just take into consideration and maybe do something different. And if you want to put it in the back of your mind, if you're a more advanced Python developer, this is where we would use mocking functionality in Python's unit test package. And because for obvious reasons I don't have time to go into a more advanced thing, we're not doing mocking in this overview. But if you do have questions about that, feel free to connect with me and ask me those questions. Anyway, because it's going out and doing stuff in the network, I can't do a straight one-for-one comparison, because my information from the file is a subset of the information that will actually be in the database, because the database has gotten information about the IP address and some other stuff. So I can't do a straight comparison. In fact, I just wrote some code to try to do that, and it failed. So what I have to do is I have to have all of these assert equals. And what you will find as you write code, unit testing type code, you will end up seeing yourself in these situations not infrequently. It will happen more than you think. So basically you need to do that. But that's how we do unit tests. And basically, as you can see from here, I went through and did all of these comparisons. I only wrote compared device down here at the bottom for Where'd my devices go? Compared device, and I say the device that I compared, and it was successful. And just so you know, for services, it's a similar thing. I do service discovery, but it's the same general idea. I do comparison of a bunch of fields. Anyway, I wanted to go into that difference between test devices / test services and test hosts, because there's a little bit that is different. There's a lot that's the same in general, but there is a little bit that's different as well. All right, one last thing I want to go over before we're done, and that's this. I mentioned as we were going through this that I did make some changes to the device monitor and service monitor functionality, as well as to the compare networks and print network stuff that we had just worked on recently as a result of me writing these test cases. And I wanted to show you what those were. Basically, they're kind of a symptom of the same thing, and that is this. In my device monitor, and the same is true for the service monitor, I had kind of lazily put this parser stuff up at the top of my file where it would get executed, because I was always running device monitor as an application. If I wanted it to be used as a library or a module that people imported and used, then I would be running into problems when somebody does something like this, and I call it things were failing in that situation. And so what I needed to do, which is probably arguably what I should have done in the first place, is I put it within this main functionality, and it lives happily there. All I really wanted to get was the thread pool size. And for compare network stuff, once again, in this situation, if you recall, I had a bunch of globals, and I was using globals to pass in, to keep track of where I was in terms of the visited nodes, as well as the stack, as well as the current data, etc. And so what I did was I made these part of the parameter list of parameters that get passed in to this function when it gets called, and I keep track of that. Now, it was a little bit trickier to do this, not really tricky, but just I needed to be aware of what was going on, and it took me a little while to figure it out. But basically, now I don't have those constants that are getting used. I have them set up within my main program, and then when I eventually call compare data, I pass in the stack, which will have nothing in it, and visited, which will also have nothing in it. And as I recurse through this compare data functionality, then I end up adding to it. And and the last thing I want to point out here is something really important. For those of you that are advanced, remember mutable versus immutable, because stack is a list and visited is a set. Are those mutable or immutable? I'll give you a second to think about it, and then I'll tell you these are mutable. That means they can be changed. So when I pass in stack and I make a change to stack, like here where I do an append, I'm making the change to the actual stack that I created in my main application right here. If I was trying to pass in something like an integer or a string, then those data types are immutable, and so any change I made inside would not be reflected in the caller. That is an advanced topic. If you are intermediate to advanced, you want to understand what I just said. If I didn't go through it in enough clarity for you, contact me or request that I do something more on this, and I'll be happy to do it. But it does have to do with everything being an object and the issue of mutability versus immutability. Maybe I'll make a lesson on that. Let me know if you'd like to see that, if you are at that level of Python where you'd like me to go into that. Anyway, that is basically what I did. I put these things in here and I removed the globals, and that made it so that I can do stuff like this and stuff like this and not run into issues. All right, so let's review what we talked about. Our topic was unit testing. We talked about system testing, which is testing the entire thing. We talked about integration testing, which is testing the integration points between modules. And finally, unit testing, where we're testing an individual unit of functionality. And the advantages are not only to make sure that the code that I wrote works the way that I expect it to, but also because they can be automated. And when you get to a larger project where you have multiple people and a lot of moving parts like this, then you can have unit tests which get run every time you make a change and determine if all the different components in the system are still working as anticipated. If you want more information, there are in the Wikipedia page, there is some useful stuff on unit testing advantages as well as limitations. I did complement the documentation for unit testing in Python. They don't always have good documentation, but this picture or this code right here is a good summary. With unit test, you'll be importing the unit test package. You'll be creating classes that are going to be your test set of test cases. You're going to be importing from, not importing, you're going to be inheriting from test case. So basically this is our inheritance because this is a class. And you'll create your test, individual tests that will all start with test underscore. And within your test, you will do assertions. They can be assert for true or false or equal, and that is what you will be doing. We looked at the code that I wrote to do this. In test recursion, we have code that does compare data. So for our compare data stuff, let me make this a little bit bigger so that you can actually see it. Here's test compare data. Down here we have test print network. Both of these are going to reach back into this recursion code, which we've included inside unit tests so that I can play around with it as I like without affecting any of the previous modules. So here I am actually going to be importing compare data in traverse and print flat, and in test quokka, if I go back to the top, you can see that I'm actually going way back and importing discovery from device monitor and service monitor. And as you can see, I've collapsed these, but here's test hosts and the code that implemented that. Test devices, remember test devices and test services did their own discovery, whereas test hosts uses these test hosts that I created in order to run its tests. I think that's about it. So hopefully that made sense to you and you now understand a little bit about unit testing. If not, or if you have questions, please let me know in whatever way is most applicable for your situation. And yeah, thanks for listening.